about, do you remember what a multiplicative inverse was?
Yes.
You do. What is it? You probably just don't remember it.
Oh, I remember it. It's like 3 times 9 equals 9 times 3.
No, that'd be a commutative property, so that's, at least it's a property.
He's talking about 3 divided by 9.
Is 9 divided by 3 times 1/3?
No.
Yeah.
Here's what I want you to think of.
It is.
3 times what equals 1?
What is it?
What's the multiplicative inverse of 3?
Then equals
Oh,
1 is
the
1/3.
reciprocal.
1/3. It's the reciprocal.
Oh.
3 times 1/3 gives you 1.
We did the opposite
Wait.
reciprocals in
What's it called again?
Then calculus.
Multiplicative inverse.
Okay.
Do we need to know that?
Not really.
So, do I write this down?
Now, what I want to build off of this is that by using inverses, anytime I multiply a number by its inverse, what's the inverse of 3/2? 2/3. Anytime I multiply a number by its inverse, I get 1. Okay? So, when I'm dealing with matrices in inverses, there's what you call an inverse matrix. Now, an inverse matrix is a little bit different. An inverse matrix is developed from powers of exponents. And I'm going to show you an example that you've already seen, and you should remember this pattern from a year or so ago. If you had 2 cubed, what is that?
8.
8, good. What's 2 squared?
4. 9.
What's 2 to the first power?
2.
What's 2 to the 0 power?
2. 0.
1.
Dang it. Everything's
What's 2 to the negative 1?
1/2.
1/2, good. What's 2 to the negative 2?
Whoa. Time out. Wouldn't that be divided by the
Wait,
2 negative
is
2.
everything?
Oh, it's just the opposite reciprocal.
Hold on. Gabby?
Is everything to the 0 power 1?
Yes.
Okay.
Everything in the 0 power is always 1.
Thanks.
Now, from what I've heard from earlier classes today, most of you guys have forgotten that you were shown this probably in 8th grade. At some point in time, you guys had worked through exponents and powers, and you've walked through and you've done the -1 power. The -1 power basically tells you that you take the value in front of it and you create the fraction. So it's kind of like an inverse. If you look at your calculator, there's a negative x to the -1.
I see it.
Everybody see that? It's right underneath where it says math.
And right above where it's like squared.
That's where that.
So if I hit 2 to the -1, what do you get?
2 to the -1.
Which otherwise known as 1/2. Okay? So what happens here is that this -1 button on our calculator is going to be called the inverse button. So here's what happens. When you're dealing with a matrix, instead of a matrix, instead of some matrix equaling 1, it will equal what's called, remember when I showed you guys at the very beginning of the matrices stuff, it was called the identity matrix?
Yeah.
What did it look like?
I was like 1, 2, 3, 4, 5, 6.
No, it wasn't.
A, B, C.
No.
At least I gave it a
If I have a 2 by 2, that means there's 2 rows, 2 columns, right?
Yeah.
An identity matrix would be this. It has 1s along the diagonals.
Because it's
I
1.
wish you didn't tell us that.
I did.
No, you didn't.
Yeah.
No.
Oh, we're
I
just
didn't
gonna-
take my notes.
What happens then if you have a 3 by 3, how many 1s would you have on the diagonal?
3.
If you have a 5 by 5, you'd have 5 1s, and so on and so
So
forth.
would be 0.
Yeah, and everything else would be zeros. All that is that what you're doing here is that when you multiply a matrix by its identity, you will get, or excuse me, when you multiply a matrix by its inverse, you will get the identity. It's kind of like the same idea of 2 times 2 to the negative 1 equal 1. 2 times 1/2 is 1. It's along that same property, or it's along the same principle. The only thing that's different now, instead of just being regular old boring integers, we're dealing with them within a matrix situation. Now, today we're not going to be calculating the matrix inverses by hand. We'll do that probably Friday. It's not that difficult. We're just going to rely upon the calculator to show how these calculations work. And everybody so far today went and got really mad at me because it made everything really, really easy. Okay? For example, what I want to do is look at a matrix equation. I want to look at the following. Matrix A times X equals matrix B. I'm just writing it out as matrix A times X equals matrix B. Remember, when we're dealing with matrices, we can call them by just capital letters. I'm not filling in the blanks right now or anything. I'm just setting it up. If I was going to solve for X, what would I have to do with the A? Divide. Now, same idea. If it was 2x equals 10, you would divide both sides by 2 to get x by itself, right? Is that also the same idea as multiplying by 1/2? 1/2 is the inverse of 2.
Yeah.
So what I do here to solve for x is I take x is going to equal the inverse of matrix A times matrix B. Now here's the only rule you have to remember. When you're putting these things in your calculator, or if you have to calculate these by hand, the inverse matrix has to go first. It's the only rule that applies here. The reason is remember, matrix multiplication is not commutative. If I multiply matrix A times matrix B, it's not the same as B times A, because the way your rows and columns line up. It's not always commutative. So in this case here, as long as the matrix A has an inverse, and we'll explain what that means here later, to solve for that variable x is all you do. It's pure button pushing right now. Let me show you an example. I want to look at this. Matrix A matrix A is a 2x2 times something gives me matrix B, which is also a 2x2. Now, if you guys remember, when you were matching up matrices, a 2x2 times something to equal a 2x2, whenever you're multiplying matrices together, these two numbers had to be the same, right?
Yeah.
That was the rule. So this one, the second matrix would have to be a 2 by, well, to end up with a 2x2, that has to also be a 2. Same idea. If you had a 2 by 4 and a 4 by 3, those match up and your result matrix would have been a 2 by 3. You remember that from when we first did multiplication? It's kind of the same idea here, and I'm trying to get you into an idea here. This value of x on the board is a matrix. It's some matrix. In this case, this matrix is going to be what dimension? It's going to be a 2 by 2. So if I multiply a 2 by 2 times a 2 by 2, I have to get a 2 by 2. Because it follows the pattern of number of rows to number of columns, number of rows to number of columns. Columns of one have to match the rows of the other. That one we would first define that with multiply. So here's what happens. In your calculator, you've got this fancy button, the alpha zoom,
Yeah.
the inverse,
Or say,
x to the negative 1.
wait, time out.
All you have to do now, to solve for what this value of x is type this into your calculator. Let me move this over.
Where do we go now? Where do we go now?
Once again, I go to my alpha zoom. I need to create a 2 by 2. I fill in the blanks. 4, negative 1, negative 3, and 1.
Who else
Outside of that, I have to hit the inverse button, which is x to the negative 1. I create a secondary matrix, alpha zoom, 2 by 2, 8, negative 5, negative 6, and 3. And with any luck, you should get that for an answer.
Oh, Murphy, you dog. I'm so mad at you. I'm so angry.
What's wrong?
I went to the terms.
That's
You get just like a regular, just the
alpha zoom.
so I don't have to hit matrix.
No. So what happens here is basically the following.
Whoa.
If I take 4, negative 1, negative 3, and 1, and I multiply it times 2, negative 2, 0, 3, my answer is going to be 8, negative 5, negative 6, 3. That's what you're doing. You're basically solving the setup of 2x equals 10. What's x? 5. Now I'm just multiplying matrices. Yeah.
Quick little question. For the, you know how you have those little things or anything?
The matrices, yes.
This, when you put a rectangle, or it has a rectangle and like a green dot above it? Yeah. Those three.
Yeah,
Those three matrices. Did you just transfer those from your calculator?
I did.
How?
The smartboard allows me to take what's
Oh,
on
you
the
use, I thought you used like a calculator.
I can
and
take
be able to-
whatever I take off. I can take anything that's on the screen of the
I'm sorry,
calculator
I
and
thought-
just throw it in.
I thought you did it from this
I
count,
did,
like
yes.
one of these, and then just like magically.
Yes, I did. I went like this, and it showed up.
You're a funny guy.
I am.
Flat three cats. No.
Did you
I
click your
wanted
heels
to-
together and say, home, Oklahoma, Kansas?
Whatever. Try it again. Same idea. When you get into the process of a lot of these things, if you're just solving a quick matrix equation, do you really need to write it out? You really don't. I mean, could you? Go for it. Because what you're doing here is you're trying to solve for x. And you're looking at the problem itself, knowing it's a 2 by 2, multiply it by something to give me another 2 by 2. That means the something should be a 2 by 2. So I can just go right in my calculator. Alpha zoom, 2 by 2. Uh-oh, what do you mean, uh-oh?
Did we get some p12s?
Oh, that's right, I forgot about this problem. I should probably show you this so you don't get scared.
Why would you do that?
Because I'm a jerk.
Have you seen that 3.3 test?
So we have 5, negative 1.
Did you do two 3.3s and then two negative? Or one negative?
All right, so everybody's getting some god-awful looking fraction, right?
Yeah.
Or decimal. Well, there's another crazy button you can press on your calculator. Ready? Math, enter, enter. There's fractions.
Kill him, Murph.
Don't give me decimals, give me fractions.
I see you out here doing things. I see you working. You working hard.
Oh, mixed numbers are evil. No, mixed numbers. Mixed numbers are bad.
Why did they teach us mixed numbers?
I don't know.
What's the? I still think that I'd go to a
Nice, huh?
They invited me.
You want to be the jerk? That's funny.
Now, we can take this a step further and do the next idea. Remember when you guys first learned how to solve one-step equations, what was the next topic?
The next one.
After you learned how to do a one-step, you did
3 steps. Or just
2 steps. So if you have a 2-step equation,
Oh my
come on,
Mr.
wait a second, relax.
You dog.
It's the same idea as
Don't you
this.
just add? Don't you just add it or something?
What do you do to solve for x if it's 3x minus 1 is 5?
Add 1.
You add 1.
That's more work.
And then you get 3x is 6. You get the inverse, and so on. Well,
No.
what do you think you do first here?
You add to it.
You add the matrix. Do these matrices match up? Do they have the same dimension?
Yes.
Yes, so when you add, or if we had to subtract, all you have to do is match up the entries. And then use your calculator to solve for i's.
That's so much math.
I can make you do this by hand.
I know, that would be so much math.
That would be.
I dare you.
Oh.
Okay? So remember, when you're setting these things through, the biggest issue that you guys will come across is when you're setting up multi-step matrix style equations, is that you might come across something with extra negatives. If you're subtracting and adding, that's the easiest thing to mess up. Now, could you avoid all of the screw-ups by typing it into the calculator with the matrices? Sure. It's just a little bit more work. Yeah, okay.
Do you, when you like transfer, like you divide, or take the inverse or
Mhm.
whatever, what do you do when, like, when you add it? Like, do you add
Yeah.
that matrix to, like, after you multiply?
No.
to-
You have to move this before you get to do the inverse. Just like you would follow the steps of a regular two-step equation.
So you
No.
would add the two together first,
What do you
and
first
then.
Then
if you
inverse.
Multiply by the.
Remember, the inverse goes first, though. So what'll happen here is you're going to wind up with the 4, -3, 6, -2. Oops. 4 plus -1, 6 and 1, 8 and 5, 2 and 7. Now you take the inverse of the 4 -3 times this one, just like we did a second ago. Always do the inverse part first. Scrunching face, you okay?
Yeah, I just got decimals.
It's okay, math and error. Give me a fraction. You're gonna get decimals.
But they're ugly.
Mixed numbers, trust me, you don't want mixed numbers in second semester. You will not want mixed
I'm
numbers.
not gonna use them in equation, I'm not like profound.
Oh, I just don't like them. So we have 2 by 2.
How do I do that?
Oops.
No, I got the Latin. I don't know.
Is that how they does it?
And I will say that every class has just absolutely loved the idea that somebody found out about alpha zoom.
It's not on
I have not
here.
mentioned who it
It's on
was.
the calculator.
I figured, well, he just thinks he's cool then. Remember, you got decimals, go with math and enter, and hopefully you got 33 over 10, 13 over 10,
They're such ugly.
17 over 5,
Yeah.
and -3/5.
You're not to discriminate.
No fractions!
These are ugly fractions.
Got everything over 5.
Yeah, and they're easy decimals.
Yeah, you know what I did with the mixed number?
Okay, don't put those together, okay? Do this to this first,
Oh, okay.
and then take the inverse in front of it. Okay, you're just doing it out of sequence, okay?
Okay.
Now, here's the part that you're really going to enjoy, because it gets really, really interesting. What I want you to do, guys, what I want you to do real quick is I want you to make a coefficient matrix and a solution matrix out of this system real fast.
Wait, what?
Remember when we set up Kramer's rule yesterday?
So basically our homework is what we're doing.
Kind of. I want you to recreate a Kramer's rule setup with this real quick. I want you to set up coefficient matrix equals solution matrix. That's all I want you to set right now. Remember, when we're looking like a coefficient matrix and a solution matrix,
Wait, equal solution matrix? What is that, just 5 and -10?
C.
Oh, yeah. So there's our homework, that's what we're doing?
what I'm creating here, what we're going to create from the solution matrix and the coefficient matrix is you're basically setting up a one-step equation to solve the system. What you're winding up with is, yes,
So that's a 2 by 1. Oh, so would that have to do X and Y?
yeah. Because take a look at what's happening. I have a 2 by 2 matrix times something has to become a 2 by 1 matrix.
You lost.
You got the coefficients correct, right?
Yeah, but I did like the same thing that I
Would
did
be
yesterday,
XY.
and now like negative.
We didn't do anything yet.
Well, oh,
All I'm doing here is this.
yeah, yeah.
Now, what I want you to think about real quick is the same idea of this, where we had, what was it, a 2 by 2 times something to equal a 2 by 1. What's the something have to be in order to 2 by 2 times? Careful, is it 1 by 2 or 2 by 1? It's got to be 2 by 1. The middle numbers have to be the same. The exterior ones give me my solution. So what happens here is, since there's two variables, you're creating that.
Wouldn't you put the both x's on top of it
No,
from the equation?
no. The way that this works is because this goes back to the idea of an identity matrix. An identity matrix starts out with x, y, z going down diagonally. X is the first row, first spot, y is the second row, z, and so on and so forth. So it drops down each column, or each entry goes down a different variable. So you wind up with basically this idea. Isn't that matrix A times something?
Just uncover it.
Isn't it matrix A times something equals matrix B? How do you undo matrix A?
Oh.
Not divide, we're just using the inverse again. So what happens here is that this xy is going to equal matrix A inverse. Using the inverse operation within matrices. Yep. Now, when you put this in your calculator, it still looks the same. Move this over. Alpha zoom. 2 by 2. Negative 3, 4, 2, negative 1. Inverse. Now, what's the dimension of the 5, negative 10? Is it a 2 by 1 or a 1 by 2? 2 by 1. And remember, what's great is that even if you put it incorrectly, it's going to show you a row matrix instead of a column matrix. So it's got to be a 2 by 1. Put in your values. 5, negative 10. Hit enter. There's x, there's y. It just basically solidified chapter 3 as being null and void, aside from linear programming.
Then what's the
That does
point of us
pencil you.
learning?
Yeah, then why do we
So
learn?
we know how to do it the hard way?
Yes. What's the point of learning how to add? And you can multiply.
Why would you need to
Because it's further down the road.
Because
There's multiple ways to solve systems, and I'm betting, don't throw anything, I can dodge it. There are multiple ways to solve systems. I know you're texting somebody to tell them that. It's awesome, isn't it? This is one of the ways that you can solve systems. You can solve systems via inverse matrices. Just by writing it up, take the coefficient matrix, do the inverse, multiply it by the solution matrix, and it gives you your x, y, z. It could be a 4 by 4, 5 by 5, or whatever. Yeah,
Wait, so can you do this with one back for you?
sure, go for it. There's one right there.
Oh, you dog.
I'm right to you. Once again, when you set this up, do you really even need to worry about writing out what the matrix is going to look like? What you need to look at here is that when you're trying to solve a system now, via 3 by 3 or anything, if we're going to do this via matrices, you could go right to your matrix and type it in. I will recommend that you're very careful when you're writing it out, not to miss a sign. Lord knows I've never missed a sign here or there.
Probably.
Okay? So take a second and solve for x, y, z. Because in the past, we've done this problem. We've done it via elimination, substitution,
Ace, get it.
half a page of paper.
Kill that.
But now there's another way. And like I said, one of the reasons why I wanted to, I'm blending 4-4 and 4-5 together here today, because it both deals with inverse matrices, is that once we get through this part today and into tomorrow, we'll be able to go back throughout the entire chapter and hit every single one of the word problems, and not have to solve it via Kramer's rule, not have to solve it in a weird way. As long as we can set up a system, we now have the easiest way known to man to solve the system. We'll do that tomorrow. We'll do that into Friday. Friday, I will show you guys how to crank out an inverse matrix by hand. There is a small formula to that. It's not very difficult, but it will be something that I'll put on the test on Monday. Remember, the Monday portion of the test will be the second half of the class period, the last 20 minutes or so, maybe 3-4 questions up by hand. Tuesday, it's all calculator. I don't care how you solve it. Okay?
So we can use,
I don't think right now the calculator is a good idea, but yeah, you can use the calculator for Tuesday, but not Monday.
But we could do by hand if we have calculators.
Sure. So let's see here. When we set this up, is everybody well on their way of typing this in?
you could say finish.
When you type that in,
Hello.
Are you transferring this class?
just
I know. Hey, your name is not Tickler. You don't have to tickle people. It's jokes.
so we have to get your stuff in here though. Okay, so you can take your calculator. I don't think you need that. So when you type this thing, that was nice for her to let you do that. Huh? So we type this in, alpha zoom. I have to start with a 3x3. So we have 2, 3, 1, 3, 3, 1. Alpha Y alpha zoom 3x1.
This is almost as tedious as making those geography or geometry projects last year.
Did you get that for an answer?
Yeah.
Yeah.
Remember, X, Y, Z. That's how it sets up. Are you really mad at me for never showing you this before?
Are we
No,
just
that's-
like going like graphing?
Whatever. We don't need to graph these. Nobody graphs 3 dimensionals anymore. Seriously.
It's been.
Okay? So what I want you to work on tonight are those.
Oh, wait.
I'll rewrite them on the board.
Okay, let's do that.
In section 4.4, it's on page 227, numbers 29 through 32.
So I'll just on the calculator.
Yeah, you can do this on the calculator.
That just made my
Oh,
study
they
all
only say-
crazy.
Okay? It's 10 problems. It's all straight calculator work. By all means. Well, you shouldn't have to, but remember, the answers and stuff like that, depending upon what it is, if it's solving for X, Y, Z, if it's solving for the inverse matrix, what you're looking for, make sure you give me any answers or solutions, if needed, in fraction form. Okay?
Alright.
Tomorrow we'll build into this a little bit further. Questions?
Mr. Murphy?
What's up?
All evens?
No, all of them.
Yes. All of them that are even and the inverse are even.
Oh.
That's it? Yep.
I don't think there are very many fraction numbers in as far as
No,
Wait, it's not really-
Even